Let us see exercise 5.1. Which of the following statements are true and which are false? Give reason for answers. First one, only one line can pass through a single point. So this is the first question they are asking. Okay, let us see it. If you take a point, how many lines can you draw so that it will pass through that point? Countless, isn't it? So for first answer is false. Okay, you can draw infinite number of lines. Passing through a given point. Let us see the second one. There are infinite number of lines which pass through two distinct points. So two different points are given, point A and point B. They are saying that only one line can infinite number of line can pass through the given 2 points. This is the first line. If I want to draw another line passing through this, it will overlap or coincide or superimpose with AB, same line. So answer is false. Only one line can pass through two distinct points. Let us see next one. A terminated line can be produced indefinitely on both sides. Terminated means ended, already ended. So this is a postulate of Euclid directly. If you have drawn a line and terminated it, you can extend it on both sides indefinitely. It is true. So a terminated line can be produced indefinitely on both sides. Let us see the fourth one. If two circles are equal, then their radii are equal. So they have given two circles are equal. Okay, circle with center O, another circle with center O dash. Both are equal, then their radii are equal. If they are equal, if you keep one on another, okay, they will superimpose with each other. That means O will coincide with O dash. Okay, O will coincide with O dash. That means they are equidistant from their circle. Therefore, their radii are equal. So the statement is true. And the last one is, in this figure they have given three line segments. AB is equal to PQ, whereas PQ is equal to XY, and they are saying that AB, you should prove, or they are saying AB is equal to XY. So this is also a direct consequence of Euclid's axiom. That's why it is true. What is it? Things which are equal to same are equal to each other. Okay, that's for AB is equal to XY. This is true. Consider two postulates given below. One is, given any two distinct points A and B, there exists a third point C which is in between A and B. Another one, there exists a 3 points that are not on the same line. Do these two postulates contain undefined terms? Yes. So answer is yes. Both points, comma, line are undefined terms. Okay, this is the answer for first one. Next, what is the other question they are asking? Are these two are consistent or not? They are asking. Postulates are consistent. Yes, these two postulates are consistent because they show different situations. What are the different situations? Okay, in first one they are saying that A and B are 2 points, isn't it? 2 are distinct points, and C is in between A and B. So definitely there will be a line, then it will be like this. Whereas in first one, A and B are line and it is not lying between these two. That means if I draw a line like this, okay, these two are not, C is not lying on the line. So these two are two different situations. Now third one they are asking is, do they follow Euclid's postulate? They do not follow Euclid's postulates, but they follow the axiom. What they follow it? Two distinct points, if are given, only one line will pass through it. Okay, children, let us see question number 4. If a point C lies between 2 points A and B such that AC is equal to BC, then prove that AC is half of AB. Explain by drawing the figure. So here in fourth question, number 4, they said that given AC is equal to BC and C lies between A and B. What we have to prove? AC is equal to half of AB. Now here, first we'll draw a figure. Between A and B there lies a point C. Okay, and I said we have AC is equal to BC. Okay, first let us write given AC is equal to BC, which is given. Next, to this AC, okay, we'll add AC on both sides. Okay, AC plus AC is equal to BC plus AC. We have added AC on both sides. Why we have added this? Equals. are added to equals on both sides. Okay, that is the reason. Now AC plus AC is how much? 2AC is equal to AC plus BC is how much? AB. So AC is equal to, send this 2 to that side. AC is equal to 1 by 2 AB. Okay. So here, why we have, since BC plus AC is equal to AB, we have replaced it. Okay, therefore AC is half of AB. Let us see question number 5. In question number 4, point C is called a midpoint of line AB. Prove that every line segment has one and only one midpoint. So here they are saying that in question number 4, if C is called midpoint, prove that it has only one midpoint. So here already we have seen C is in between A and B. This is 5th question. Now we have to prove that it is only having one midpoint, that is C. Okay, so let us assume that, consider that there are two different midpoints, C and D of line segment AB. So here C is already there and D. I am considering both C and D as midpoints. Now if C is midpoint, what will happen if C is midpoint? AC is half of AB, isn't it? That implies 2AC is equal to AB. Okay, B equation 1. Now but we consider D is also a midpoint. So D is midpoint means that implies AD is half of AB. That implies 2AD is equal to AB. Equation 2. Now compare from 1 and 2. Okay, when you equate equals, AB is equal to AB, so 2AC is equal to 2AD. So AC is equal to AD. So when they are equal, isn't it? From axiom we know that things which are double of the same things are equal to 100. So from axiom, things which are double of same thing are equal to one another. That means if 2AC is equal to 2AD, AC is equal to AD. So if AC is equal to AD, that means what? C, D coincide. So C and D are same points. So our assumption that AB has two midpoints is wrong. So every line segment has how many midpoints? One and only one midpoint. Hence proved. If AC is equal to BD, then prove that AB is equal to CD. They have given a line segment AD and BC are lying in between these two. They have given AC is equal to BD. To prove AB is equal to CD. So let us start doing this. So from figure we can write that AC is sum of AB plus BC. Okay, and similarly BD is equal to BC plus CD. This is from figure. These two we have written. Now AC is equal to BC plus CD. What is the reason? Since AC is equal to BD, isn't it? So let this be equation 1, this be equation 2. Okay, so from 1 and 2, AB plus BC is equal to BC plus CD. Okay, so subtract BC from both sides. So AB plus BC minus BC is equal to BC plus CD minus BC. So this becomes 0. These two will get cancelled. So AB is equal to CD. Hence proved. So let us see 7th one. They are asking about axiom 5. The whole is always greater than part. They are asking why it is considered as universal truth. So this statement is universal truth because part is always included in the whole, isn't it? Included means inside the whole. That is the reason actually. For example, you take any line segment, okay, AB, and take some 2 points CD on it. Okay, then what will happen? AB is sum of AC plus CD plus DB. From this you can clearly say that AB is greater than AC, AB is greater than CD, and AB is greater than DB. So always whole is greater than part. Okay.